Hello, everyone. Welcome to a new episode from ClearSpot. I'm the general manager of the company. Today we're gonna discuss, I think, an interesting topic for whoever is in charge of performance optimization in solar plant. So if you manage more than 20 megawatts and ideally you are interested in understanding and defining the five most common and expensive mistakes which can happen, I think this episode is for you. So, before starting, feel free to review the agenda as usual. Um, so, today we are going to focus on what so far in 2024 we knew it was an accumulated cost of over 10 billions in preventable loss. So, this episode will focus mostly on the five most expensive problem and the best way to avoid them. So for sure, the first one, which has been identified, and I repeat before starting, we have other 90 validated resource from the industry, other players and providers. Um, so the first problem, which has been identified, is the reactive maintenance, the cost, financial breakdown. The second is thermal monitoring, which so far, unfortunately, is not so common in the industry. And the data integration is the third one. So, what is the blind spot and the cost of missing those anomalies and um, even combining all this information and data together? Wiring issue, which, so despite the awareness, is still one of the most common and expensive problem, which lead to failure of the system. Performance testing is the fifth one. And after we'll go through the best strategy to implement to avoid those, and eventually even the best technology, which could fit in your system and help optimizing the performance of your assets. So the first problem, so as we know, reactive maintenance is still a common, I will say, practice in the market. Not everyone um, due to different, I will say, reason from system enablement, expertise, and even training. So far from operators, and even I will say awareness um, from manufacturers is one of the main reason why system unfortunately still fail, and people on site unfortunately they have to react uh, rather than anticipate those issue and challenge. So to that we are going to explore the direct cost and how it could look like if we could move toward a more proactive maintenance. So basically, and start anticipating what could fail rather than acting once it's too late. So we know that despite the direct and indirect cost, some of these, for whoever will require this document, for sure, I already mentioned all the use case, business case, where actually we gather all the information. But for sure, we know that this approach normally leads to the type of cost which over 100 megawatts we could talk about around 200 or $300,000. So for sure, a lot of studies showing that how reactive maintenance is costing so far over $5,000, and this cost due to climate change and weather. So the weather pattern are changing is increasing consistently over time. So this is why it's like it makes sense for you and your team to look into this specific aspect. Um, we know that inverter failure is one of the most common, for sure, reactive maintenance triggers, which actually is creating operational disruptions. Indeed, data reveals that so far inverter issue related cost 40% of the system downtime. Because I think I think it's quite common right now. It's not the first episode we mentioned this information and data. Um, so there are several studies confirming that the inverter failure caused 36% of energy losses, while the module failures contribute only to 5%. So as we can see, there is start seeing a correlation between the proportion and how much those failure affect the health of the panel. And so far, I think this could be one of the um, most interesting for the industry to pay attention. Traditional approach. I think this is quite standard and this is quite even known. But sometimes, yes, for budget can be from the EPC construction phase or even sometimes from the PPA discussion, which this cost is not anticipated. And we see that this becomes challenging after for the maintenance team after once the sites are delivered from the EPC team um, to raise their hands, requiring more budget for fixing things which normally um, shouldn't break, but they break. So for sure there is a portion of complexity from monitoring system maintaining them too. Historical presence so far could be from a mental standpoint in terms of perspective blocker, and we see that a lot. And at the same time, yes, there is a lot of silos. There are a lot of silos actually between different departments, um, which are affecting the idea of having a more holistic approach, a more I would say even effective way of monitoring and start anticipating what could be predicted and identified in advance. So for sure, one of the main things I would say to retain from predictive maintenance is the capacity of the system to learn. First of all, to have a better monitoring, more holistic one, which can for sure learn from previous pattern, which is this the beauty of data and AI, machine learning, where actually once our system has enough information, even from historical data, despite the approach used, becomes easier to identify the specific anomalies. And once we want to understand even the root cause of those issues, it's easier even by having the right access. We'll go through later, but for sure we know that one of the main is the thermal pattern analysis. In terms of visual spectrum of anomaly detection, uh, whatever can be so far identified from cameras, and we know from hotspot, even diet, or a crack, micro crack, or soiling, for sure, once we update the information at a pixel level, which actually help us identifying specific location with electrical performance correlation, it's really possible to have a specific advantage and get to a predictive model which can be really effective and precise in pinpointing the location and the root cause, which so far seems to be one of the most common and yeah, challenging from whoever works or is in charge of the performance of the site itself. Implementation roadmap, we know that to start from audit is essential. Audit of the infrastructure, the data quality is one of the um, I would say the most essential. So far, it could lead to a failure of the system and unfortunately even a reliability of the data. Um, in terms of pilots, for sure, always start where it makes sense, where data are available, where there is openness. If you can have access to thermal imaging and visual inspection technologies, for sure, it's always recommended. Why? Because unfortunately, leveraging and relying only on one specific sensor data type or system, unfortunately, give just one side of the story. So the full point here is really trying to get and as you know, your team goes on site, you see problems and can communicate accordingly. Drone just allow to do it faster, quicker, and to pinpoint specifically accurately the location of the problems. We always say start from what makes sense financially. Scale as soon as you're satisfied, it could be 5, 8, even eventually later. But implement and scale. Where do you think the use case makes sense? Where financially can be justified to the other with the other shareholders, and at the same time could be clear. Um, in terms of continuous optimization, like whoever works in maintenance know it's a process, it's a journey, it's not a sprint. Same for best practice. How to measure the success? We know that the mean time between failures is one what the target should be between 30 and 50 on downtime reduction. Uh, in terms of maintenance cost per megawatt, the objective really should be to bring that cost down to 20-30%. System availability. I think for all the O&M manager or expert, we know the objective is really keep it higher, as it shouldn't be below 98%. Once we go on the thermal is where I will say in some areas maybe more technological advance. It's something common for bigger organizations. It's something common for bigger O&M players or IPP. Something more common as a gigawatt scale because they know. But for whoever is as a portfolio, as to maintain a portfolio which is lower in terms of volume of size, thermal could be something not known or where actually we might lack understanding of the importance of this monitoring. But so far, we know that exceeding 20 Celsius of ambient operating condition, you could start reaching level of 130 of higher. Why this is important? Because once those anomaly affect specific cell or panel or module level, we start seeing that there is a higher level of degradation. What is alarming trend? Hotspot prevalence jump from 0.24 up to 0.81% between 23 and 24. So we see an increase in terms of, and with manual inspection, the main problem is actually it's missing more than 60% of critical hotspots. So which once they go undetected, they can cause miserable production losses. Root cause. For sure, root cause, different reason why hotspot happen, they are in place. We know the bypass diode failure, which are critical protection components, serve as the first line of normally defense against hotspot development. So we know that when functioned properly, normal bypass diodes activate within a millisecond to reroute current and around shaded or damaged cell. But in case of those failing, I mean, this normally is one of the most common, so you should really pay attention. Partial shading is another one, which normally reverse the bias condition in affected cells. And even normally smaller can cause disappropriate performance impacts. In terms of cell microcracks, normally is what it's hard to normally it's invisible during visual inspection. We know that it could affect the structural and disrupt even the current flow. Normally, sometimes can come from the manufacturer side. So if your APC didn't do properly during procurement, or even once he received the panel, for sure, I mean, something should have been detected in it previously. But if it's the case, pinpointed with specific level of accuracy and precision and resolution is really vital in order to make sure that those anomalies are identified. Several manufacturing defects, for sure, normally either about irregularity or interconnection or even contamination, which can introduce resistant points that convert electrical energy into heat rather than usable power. And as we know, wiring and connection issue as one of the most relevant, which will be discussed in the next session, in the section number 4. So stay here if you're interested in understanding more. So what are the impacts? I think the impact is one of the more most relevant information that you might take with you. So once those bypass diodes start activating to protect against hotspot damage, an entire panel section can stop producing energy. So we could directly and immediately produce a power loss of 33% per activated diodes. So yeah, for 100 megawatts installation could cost up to translate 33 megawatts of lost capacity per affected string. Um, for sure, there is an acceleration in degradation. Catastrophic failure risk uh, can cause glass cracking, solder connection melting, and complete panel failure. In terms of financial impact, where the money are, and speak 49.7 of module failure involve normally we know hotspot related damage. So for whoever is not aware, whoever is not performing thermal inspection analysis, I think those data could raise awareness, even internally, if there is some resistance or as it could be something new they haven't heard about. Even if I spoke with maintenance leader, who unfortunately, despite doing this job for years, they weren't completely aware about the output. They know about the output, but they weren't aware about the level of impact. Um, so always, I think, interesting and important to pay attention. Traditional and more advanced approaches. I mean, traditional, we know, I don't know, for whoever perform, maybe you will have FLIR gun or any thermal gun. Normally, people take sample, normally, people run, even then you have to walk in the site, so you understand the limits in terms of speed, in terms of accuracy, in terms of reliability, because unfortunately, a simple sample, cannot really help in identifying the health of the plant, of the full plant. So the objective is always to rely on a more specific tools. Drones are really effective in this task because you can set, first of all, the flight plan can be programmed. They can follow a specific route and path, the right dimension and perspective from the floor up to the sky, and in terms of altitude. And yeah, they can have, we can talk about thermal gun, but there are other kind of integration, we say payload, which can be added in order to really pinpoint. And the kind of resolution that the camera right now have is really effective to pinpoint specific kind of issue, which normal will be undetectable from a human eye. So detection technology, yeah, we were talking about infrared thermography. We know they perform a certain kind of wavelength range. Ultroluminescence normally is performed from the manufacturing company, uh, to understand the electrical defects. Implementing that, I would say there are a lot of reason why implementing. So these are one of the use case we found. Even we try to not use anything from our side, just to be more objective and leveraging more industrial data, which are common in the market. Why? So I think even this information can become more reliable, and you can correlate more with them. So this is why actually will not fire any example from ClearSpot. So in terms of benefits, I would say even for whoever wants to start performing anything internally in-house, for big organization, whoever is a data science team or a team more dedicated to projects in terms of innovation or AI adoption. If you have a computer vision engineer, there are a lot of advanced architecture in terms of CNN. Um, like YOLO is one of the most common for sure to detect. We have even solution to pinpoint on site on the drone itself on the edge. This can be done. Um, the main objective is even to reduce the early false positive reduction, which I mean at the end is one of the main reasons, even because you don't want to waste time on site trying to find or validate a problem which should have been detected properly from the beginning. Right, so this is really important. The system reliability, especially for who is exploring or has explored in the past and maybe had a bad experience, I would say is one of the most critical. I would say criteria if you can have one, because you don't want to waste time with unreliable system, and invest in something which unfortunately can become expensive if it's not effective. So the predictive capabilities can be integrated once. I repeat, the thermal imaging or the visual inspection aspect can be correlated with the sensor IoT. Hopefully, you have IoT sensor. It then coming from the manufacturer itself, either invest in weather station or more advanced system to actually add all those information which ideally from a normal SCADA system you wouldn't have. So if you invested in those and you are already aware of, and we have an episode, we have another episode, is the title is 100 um, million with AI saving, adopting AI. One of the main with Matteo we discussed was actually a IoT investment. So if you have invested in this hardware and normally are not cheap, are quite expensive, your main objective is to make sure that this investment is paying off. So thermal imaging, visual inspection imaging is great to have a realistic and full analysis and state of your site. So in cost benefits analysis, yeah, the saving can be huge outside of the licensing cost. But once we focus on the downtime, we can really start targeting 100 up to 200,000 in terms of saving based on the size of the project. It's around 100 megawatts. So if you focus on point number three, it's a data integration system interpolarity. I think whoever worked with data knows the challenge of integrating in a system or infrastructure which actually present those information in a fragmented way. And unfortunately, it's something which, if you invest in system and those systems are expensive, you really don't want those systems to be unreliable, or you don't want this data to be less actionable or insightful. So the consolidation, I will say, in the whole software industry, I'm not talking just about in terms of solar, is one of the most challenging from one side, but even most, I would say, impactful um, action you can take, because especially if you invest in system, you want a return on investment and you want the information to pinpoint, especially what is the specific problem. And sometimes for a specific high-level correlation, once we're going to want to get to strength inverter tracker level, you really know that without an advanced system to monitor, to track, it's really hard and challenging to get that level of granularity of information and accuracy. So the mismatch classification. For sure, if you are relying on any type of system, you want to make sure that whatever we call in AI, in the AI space, you labeled as correct information. It can be from visual, can be from sensor. Actually, it's in the old type, any type of data, whatever you label as in a way, you want to make sure that you label correctly. Why? Because once it's like you train a system to find something, you want to train it right. So for whoever is leveraging something or want to explore something in-house, I would say first you need to have the technical expertise, which come from the IT, AI, or tech space. Second, you have to, and normally this is your expertise, either if you are OM, EPC, or IPP, you want to make sure that you are labeling the problem correctly. What you don't want is you invest a lot of time, a lot of research in plan projects, a lot of people, a lot of awareness, a lot of emotional investment, even personally, to end up having something which it's unreliable because actually was never trained properly. So I've seen that when I talk with prospect, especially about previous investment tools. One of the most common, we could talk from a visual perspective standpoint, is the lack of sometimes accuracy, a lot of false alert, those systems to repeat. Software providers can be the best. I will say this is why we collaborate with a lot of people on the ground to do it right, because it's where actually you can lose a lot of time and money. And if you pay for a system, you want to make sure that the training of the system is done in a way that will be reliable. So interpolarity for sure is something which is essential, imperative. So seamless data flow across multiple system and layers is actually seems like to be the essential aspect. Either if we want to think from a vertical standpoint, from the ground up to the your system, which can be your CMMS or SCADA, or from the field level, you want to make sure that everything is reliable, is connected. So how can you achieve interpolarity, and how can you achieve for sure follow the standard, even in from implement communication standpoint of protocols. Either could be from SCADA, despite what kind of API you want to rely on. for your integration implementation. What are the benefits? For sure, I mean the time, the speed, the level of monitoring, the time frame where actually these activities are performed can be drastically reduced. Cloud-based engineering, I mean, once you know about the system, if you can leverage and you want to do it in-house, I would say sensor data is what makes and all the model of machine learning, which actually are, I mean, whoever is in the open space, look into the open space, there are a ton of model in the solar, especially. Some of them have been trained. I would say are quite reliable. But for sure, for whoever is exploring to implement those model in-house, either if you have a team, normally it will be easier. Yes, will take some time. If you have your own data set, I would think you have a huge advantage. But if you like team, and normally if you like time, or time it's a cost burden, and you want to skip that, I would say leveraging a third part uh, provider can save a lot of it. But for sure, I repeat, what for any software provider, for any organization, in terms of system reliability, the essential aspect is to have the information in a structured way, and the system can communicate with all the protocol in place to provide a reliable insight. So what are the most common integration challenge? Legacy system compatibility. For sure, I mean, we know that multiple manufacturers come into the picture. So what you can do, try to implement protocols, actually can translate for whoever is building from the middleware platform that can bridge the incompatible system. Number two is data quality and validation. We said that, but it's better to repeat even more than two times if it's required, because where we see a lot of people who actually have normally the expectation cannot be aligned is where they say, I want to do AI, but you don't do AI just because your board is pushing that, or your CEO is forcing you to do it. You do it once you create an environment that actually the system and allow you to do it in an effective way, because what people don't want is to invest a lot and get a bad return, which is even worse than no return. So data validation is important mechanism. If you can put that in place, avoiding redundancy of sensor, critical measure, and I would say even filtering all the noise, which so far is your SCADA system should be full of it. So if you manage this more in terms of data governance, is whoever is if you have a CIO, CTO, he will be aware of it. If you have a tech expert on site, your organization, you will be aware of it. Hopefully, if you are in, if the hiring process was effective. Security and alert protocol. Actually, I think this is it's something which so far is not that common. But with the cyber threats worldwide right now happening, I think it's something which people in the industry will start putting more awareness. Let's start having more awareness of the topic, because especially as infrastructure become more essential and vital, I'm not talking just about data centers, which are becoming in terms of security as second, as main infrastructure to protect even during a crisis. So the whole system will rely from a grid perspective, they have to be protected. And unfortunately, I do not think so far, outside of what manufacturer put in place, a standard software provider put in place, that there is enough awareness about this specific topic. Maybe because something happened so far at a big scale. I mean, we have seen what happened. Still, the reason I'm not clear in Spain. I would say this year, but the whole grid was affected. Not sure it was directly correlated, but for sure, IT security. If you have a software provider partner in that space, I would say stay in touch with them. Make sure that everything is in place. Scalability and performance, for sure. I mean, something on cloud, it's can be effective with a mix of edge computing for what? Pre-processing, for keeping information on the edge, sometimes either for reliability, speed, and sometimes even for security, because you don't want to share your data I mean, you have to in certain cases, but if you can avoid that, software providers were the first recommending do things on edge. It's faster over time. Maybe not if you invest, but over time it could become even uh, more effective. So, how do you measure data integration success? Key performance indicators, we know data completeness, target over 99%, data latency, normally less than 50%, system uptime, I mean, more than 99.5, alert accuracy, which I would say the true positive is of total alerts. If they can stay over 80%, you've done a good job. Cross system visibility, I don't know where the average system right now could be, but a target of 100 maybe it's ambitious, but could be something to target. Um, Decision life cycle, if we can keep that closer, below 24 hours for not critical, 4 hours for critical, I think could be effective. The path moving forward. So first part, first phase, map existing data source, identify integration priorities. You want to make sure you establish data governance framework from the scratch, from the beginning. Quality standards, select integration platform, define architecture, CTO, CIO, third party expert. You want to make sure you're doing that right. So you want to connect your SCADA, virtual monitoring, weather station, whatever you have, you want to put all in. You want to make sure that data is validated, it's filtered, and whatever will allow you to monitor based on you what you decide to choose, you make sure that it's integrated. So you can put the AI once those tips are in place. You can put a lot of analytics. You can put a lot of more than analytics. More actually, is the intelligence. I would say the intelligence where intelligence can come in, and you can put the right model in place for sure. Make sure that your area in terms of predicting more historical you have, more the system can be trained on the specific site, location, environment. And people sometimes they don't think about that, but the environment can play a big role in affecting the performance of your site. Even the same manufacturers. Sometimes we forget, but there are manufacturers actually, their panel, they're not that effective. They give you a warranty. They say 25 years, you're covered. And after you start having the need of raise a warranty because the panel has start having issue, which wasn't not expected. You've done your job, everything was fine on your side, but still missing. So optimization, as we said, you keep doing it. You keep optimizing. You are in the maintenance space, so you do its consistent work, showing up and optimizing it. So wiring and connection integrity, the silent epidemic. 83% of inspected projects, normally this is on, I would say some use case we gathered of inspected projects have wiring connectors problems, making the leading cause of solar system failure in 2024. The main reason is, what is the reason? I will say. What is the lead cause or the root cause? Understanding the root cause. So, detailed analysis of 6,000 photovoltaic connectors from rooftop PV system between 2014 and 70 provide and present the insight to failure modes and causes. Most common failure causes: tight wire bending radius, 2.2 of connector affected; excessive dirt and contamination, 1.3 of connectors affected; and loose nuts, 1.1 connector affected, but with a critical failure rate of 41% for affected connectors. I will provide this documentation for whoever wants to do this documentation. Please comment in the link here in the comment section. What you want to know is the root cause. Normally, good news, bad news can come from the EPC. I mean, we know that improper installation, inadequate installer training on specific connectors type. Maybe a lot of manufacturers have often new tools. Sometimes EPC, therefore enablement, if for time speed, they know they are effective if they deliver not on time. They want to make sure that they do it fast, and unfortunately, they don't take the right time to do it right. Incorrect installation tools, maybe then for speed, I repeat, to cut the cost, reduce the expenses. They didn't use the right in tools instead of manufacturer specific crimping equipment, which can either apply excessive force, damaging internal contact springs, then fail to verify the complete engagement before locking. So EPC, if you're listening, I was saying take notes. Lack of trained personnel. I will say this is really common. More I've conversation, more this it's a pattern. I think personnel, which lack of training, is one of the actually the root cause of a lot of issues from installation up to maintenance. Of course, meeting different brands, I would say it's another point too. Uh, there are industry standard, but total design differences affect seal compression, contract pressure, long-term reliability. So these were a Taiwan study. Uncertified connectors, equipment lacking international standards, and certification raise concerns about material quality and contract design adequacy, and incorrect material selection. I would say a lot of trees could come up below the. If we think about root cause, EPC is not doing the right job, maybe, most probably. Didn't use for time, speed, cost, right tools, right personnel, best practice, hardware, a lot of components, not following the right guidelines, and use, I would say, uncertified connectors. Performance and safety, I would say, we can skip that. I mean, we know the importance of connectors and pay attention as, with in terms of degradation, the degradation at the end in the terms of all assets is progressive. So you want to make sure that you are monitoring it, and you want to make sure that you avoid that before you have any cascading effects. So prevention strategy from visual inspection protocols, annual visual inspection, all accessible connections, specifically looking for discoloration, indicating resistant heating, physical damage to housing or ceiling components, signs of moisture, ingress, or corrosion. Probably sitting and locking all connectors. Thermographic analysis, you want to make that in order to avoid identifying those. Temperature rise, one of the main one, greater than 50 Celsius compared to connectors. Connection indicates a critical issue requiring immediate remediation. Electrical testing for wire resistant measurement during commissioning and periodically thereafter to establish baseline values. Yeah, there are preventive replacement programs. Whoever is approaching their installation 10 years of operation practically replace connectors in high stress locations like combiner box inputs, invert DC connections, and environmentally exposed junction points. While this represents an upfront cost, it prevents expensive emergency repairs and production losses. We know that. Quality control during construction. If you're an EPC, you know that. Maybe you feel a bit guilty. Do that. Use the right certification of installation, the requirements, follow the requirement. Tool material standard, provide manufacturer approved tools for all the installation. We said that. Quality control inspection. You have multi-stage inspection protocols with inspection at road in before backfill. And what else? Environmental protection. Ensure all the proper cable management, preventing tight, spending radius, stress relief at all connection points, adequate drip, loops, preventing water entry. Remediation best practice. When connection problems are identified, rapid and effective remediation is essential. What do? Immediate action for critical issue, over 20 Celsius temperature differential or visible arcing. De-energize affected circuits immediately using proper disconnect procedures. Dispatch qualified technician within 24 hours. Schedule remediation for moderate issue, between 10 and 20 Celsius differential. Schedule the remediation within 30 days. For 5-10 Celsius differential, no visible damage. Increase monitor frequency to more thermal imaging. Track temperature trends, identifying progressive degradation. Schedule replacement during next major maintenance outage. Include in annual inspection scope going forward. Performance test. We had this, I think, last episode, we talk a lot about performance, all the indicators. So one of the most costly yet preventable source of long-term underperformance is inadequate commissioning, and performance testing. Um, yeah, 8% points higher than an inadequate test installation. It's quite high. By 8.6% due to insufficient commissioning, representing hundreds of thousands of dollars in lost revenue of our project lifetime for a 100 megawatts installation. I'll say, I understand whoever's listening, reading. It's hard. It's hard to use resource. It's hard to even having the data sometimes to raise the awareness, to gather the consensus and explore how to start implementing something that could affect over 20 years. When people say they don't care, it's harder to explain financially, it's harder to explain technical to shareholders audience, which is mostly financial, if you need to rely on a lot of people in this industry. When we start talking about the PPA, they understand more about numbers rather than about inverters, connectors, combiner, thermal imaging. We know that. So, but what is the point here? At this point, we are talking about one of the most common assets in terms of energy space. The responsibility is this industry will require awareness. There is awareness, but I will say why I'm repeating this because I see technical people saying, yes, I hear you, and more director level, C level, management level, being a bit more distant from these topics. I don't know if it's they're intentional, it's an intentional decision. But what I'm trying to say, it's your job to raise awareness. It's hard because so far you know that someday something is gonna happen, and sometimes I understand it can be something bigger than your scope. Your job is to monitor, is not to change the rules, and then this is actually the part of what we said. So if you follow until now, I can give you more context even about what we do. We're actually outside of helping you saving time, hours, in terms of identifying and pinpoint the right issue, which can come from thermal imaging, visual inspection, sensor analysis with correlation. Now we are integrating even solar AI agents, where tomorrow the idea is you can monitor and manage your own agents and they can autonomously perform their task. For sure, reliability is the first component because if it's not reliable, you cannot, give any authority to the system or permission to execute the job. But what I'm trying to say is, will take time. If you are watching this, means you are interested, you understand, you know that there is something else you could do, and I will say something. Expect some constraints, expect some resistance, not just from the system. May expect some resistance from the management. Expect some resistance from the environment. It's not an easy job. Maybe you didn't pick solar either if you are US right now for a specific reason, maybe just because you want to be part of a green movement. So if you are watching this, ideally, you really want to have an impact. So what I'm trying to say is, I think it's part of this impact to raise this awareness and touch points with normally people. Manufacturing is not in their agenda, is not in their propaganda. I will say raise the issue about those problems because they have to sell their modules. So it's your job. EPC will never tell you I didn't do properly my job. And I understand your position. You just need to take care of the plan. That the reality is, okay, this is my job. There are my tools. What can I do? So those information is to validate that if things are happening and there are problems, you are fully aware that the problems actually they're not for your lack of practice or lack of enablement or knowledge. They're coming from a bigger, we always say root. If you leverage pattern recognition as a skill, it's really try to find the root cause. It's those systems, they have to be in place before the job. So if you're exploring to implement adopting, I would say it could be interesting to connect. We hear that a lot, so we know how to handle even internally objection. Sometimes can be the most, I say the biggest constraint. The inverter and downtime factor. I think we know inverter malfunction represents particularly severe commissioning related issue causing 40% of all system downtime. Yeah, it's quite big. When not properly addressed during installation or initial operational periods. Comprehensive inverter commissioning requires testing firmware configuration, protecting setting, green code compliance, communication interface, thermal management under various load conditions. Don't know who perform all of that. I hope your EPC are doing it. So that reveals indeed that inverter failure accounts for 37.43 of all equipment-related power losses in operational system. With all the average repair time and major breakdown reaching 80 days, many of these failures trace back to commissioning oversight. Incorrect parameter setting, inadequate voltage right through configuration, improper grounding, communication setup errors that manifest month after COD. What are the commissioning best practice? If you're listening, if you're in charge of that, take notes, IV cure testing protocols, IV cure, maybe not all of you are using it, are practicing it. But it's one of the industrial best practice recommended in order to test on a minimum of 10% of sample of strings, either during commissioning, there are percent of projects using first-time contractor equipment. What is the purpose? Immediate quality verification, performance baseline establishment, warranty documentation. Guys, warranty. Documentation. Manufacturers will not give you your money back without documentation. Normally, you know that. So provides evidence for future warranty claims if model underperformance. Performance factor threshold. While many commissioning specifications use 70% fill factor pass-fail criteria, leading owners implement more rigorous standards. Baseline performance rating. Establish a baseline PR within the first 30 days of commercial operation. Why this baseline? Because it should be calculated using weather data, radiance measurements to enable meaningful comparison during operational life. What should be the targets of PR? Well, it depends on the system design and location, but 75 over 75 normally is generally considered acceptable. With more than 80%, which representing an excellent performance. Key performance indicator thresholds, performance ratio over 75 minimum, with specified target based on design, system availability over 80%, fully healed with 5%, fill factor over 70%, all string test. Multi-phase testing approach, leading commissioning specification. We know that multiple project stage, pre-energization testing, continuity resistance verification all ground and bonding system, insulation resistance testing, open circuit voltage verification at string level, initial commissioning. We know capacity testing with the regression models. There are some approach, PPI index, say for calculation we target 0.1, 0.9, 1.1. With inverter protection setting verification, SCADA system integration, documentation review. Second commissioning, 6-12 months. Once energy performance index, we have an evaluation using full year operational data. So we have more context, more information. We are more capable of pinpoint the performance model and validate actually what is the degradation, which remains within manufacturer specification identification of any issue emergent during breaking-in period. Long-term benefits, we know operational baseline, degradation tracking, maintenance planning, asset validation. Common commissioning pitfall. Number one, weather dependency ignored, conducting performance testing during suboptimal condition, low radiance, cloud, extreme temperature, produce unreliable results. Inadequate documentation, failing to create a comprehensive as-built documentation with test results, equipment serial numbers, configuration setting, and anomaly discovered creates problems throughout operational life. Solution, implement digital documentation system, a commission in a data in searchable, accessible formats. Single point in time testing, relying solely on initial commissioning without secondary verification up to 6-12 months. Guys, if you're not doing it, it's on you. You know you should do it. Sampling strategy errors, testing too few strings, or selecting more representative sample fails to identify a systematic problem. Solution, use statistical sampling strategies that ensure coverage across all equipment, vintage, location, and installation crews. Ignoring environmental normalization, covering test results to nameplate rating without correcting for temperatures and radiant produce misleading conclusion. Solution, always normalize results to standard test condition using measure cell temperatures and radiance. Technology evolution in commissioning. Modern commissioning increasingly leverage technologies such as drone-based inspection, IBQ testing, digital twin creation, computer digital models, built-in systems that are referenced for entire operational life. These models integrate with the civic specification, actual equipment parameter, and commissioning test results. Real-time performance comparison, cloud-based commissioning platform enable real-time comparison and measure performance against design expectation. How do you measure commission quality? Persure performance ratio should exceed 85%. All commission system. Well. Warranty claims field, higher is better, indicates throughout documentation of issues. Issue identified pre-COD, more issue found before accepted reduces operational problems. Time to full production, will commission system reach stable operation faster. Section 6, I'll say, most important here, implementing comprehensive OM strategy. So if you're OM so far here, it's been more than 1 hour, almost 1 hour. So congrats, you're still here. Maybe the topic was interesting. Maybe you didn't have anything to do today. I don't know. Glad you're still with us. The integration imperative. 5 mistake detail in previous section. So to recap, reactive maintenance, inadequate thermal monitoring, fragmented data system, wiring issue, and insufficient commissioning rarely exist in isolation. Instead, they turn and compound, creating a system of underperformance that exceeds the sum of individual problems. So what do best OM? And I think I have a document you can request about the best practice in the OM space. I think one of the best OM providers, I will say, even ensured theirs, which was quite comprehensive, quite effective. You need a predictive foundation. Shift from reactive. Please, 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 if today we want to send a message, stop being reactive, stop fixing once it's too late, start monitoring. Before problems show up. Why? You don't want to replace, you want to avoid, if you can, minimize the root cause and fix that. The reality, you need to fix the root cause. Then it's an output coming from solving accumulation, but you want really to do whatever you can since it's your scope, your OM, it's your scope, you want to do it in advance. Predictive foundation, shift from reactive to predictive maintenance using AI-powered analytics for forecast failure 3 to 6 months in advance. Comprehensive visibility, implemental management program to detect 90% of output. Quarterly inspection. Guys, you don't need to do quarterly. You want to start annually. Start seeing how many outputs you find. As soon as you define the numbers, as soon as you see the cost of detecting those, you'll say, you know what, actually, let's do it more frequently. And you start doing it twice a year. And I say, but there's still some. You start doing quarterly. So at the end, they'll start saying it, you will find so many problems. They will start thinking, okay, can I understand where it's coming from? And you start going into root cause. You start looking at your IV curve. You start looking into your SCADA system. You start thinking, correlating it with the weather condition, your IV curve. You start correlating the SCADA and the performance, your PR. You will start doing those things. It's a cascade effect. Once you start seeing the picture, you start, and since it's your scope, it's what you like. You are in the maintenance space. You don't like issue because you need to fix them, but you like to find them because it means you are doing properly your job. So start doing it, break the silos, integrate SCADA, inverter, monitoring, management, weather. Guys, more IoT you invest, please integrate properly. If you don't have a system, you don't want to do it in-house, we are here, but do something. Please do something, invest. Your investor want a healthy side to produce. And sometimes they don't know neither what they need. Reality, guys, you need to raise their hands, raise awareness, speak up. I know it can create maybe problems, but speak up because you won't have a problem you will have to fix later. So this will be available for once in the documentation, organizational readiness. I think it is a big pain point, but let's talk. Organizational factors critically influencing implementation outcomes. I think we know. I think you know that. If you try to implement, I think you're aware of it. Sponsorship. Do you have it? I don't know. If you have it, great. If you lack it, good luck. because you really need it. OM transformation requires visible support from senior leadership. Why, guys? You understand whatever it takes more than time horizon bigger than 6 months, 3 weeks, 1 month. People with perspective is people with context. People with context normally think short term, long term. Long term means they are thinking, guys, all this issue, which for you is it's a replacement cost, it's a small, but in the big picture for someone who is an owner of this, who is in charge of performance, who is in charge of customer satisfaction, your leaders want a better site, they want a better system. The reality, there are a lot of priorities. The reality, sometimes you don't know. It's fine to not know. No one knows everything. This is the point of being here today. Like spend some time to trying to get more things, more information. But you need to overcome this resistance. Resistance. I think from a background of sales guy. Resistance is part of human nature, psychology, people, human nature. We don't like to change. It's normal. So, but what we don't like more than change is the consequence of not fixing the issue. So the problem we more likely will have. We don't like problems neither. We don't like consequence. We don't like the pain. So you want to raise awareness. You want to get more, I would say, consensus and support. Start raising this issue, not just from a cost perspective, from an emotional perspective. Who wants to wake up sometimes? Okay, on Saturday there is a critical issue and say, family call, you're with your family, you have to fix that. You say sometimes a certain problem cannot wait. Critical issue cannot wait. You have a fire, well, no, cannot wait. So you are aware of it. You want to avoid those events from happening because you know this could affect your reputation. You are the manager, you are the decision makers, even if you are the technician, you know that tomorrow a problem will be on you. Tomorrow you'll say, why did we didn't fix that before? And the reality, you want to avoid that. This is why, at the end, it's a cultural shift. Yes, it's a cultural shift. Change management, yes, too. But we need to. No one's like to be a firefighter, right? We want to be in a safe house. We don't want to fight. We want to be in a comfortable position. But how to? We need to start changing maybe even the metrics we are using. Maybe from uptime maybe to performance. And I was saying maybe OM it's over. The future, I think, is still performance engineering. It's no longer fixing things, just making sure you optimize the hell out of it continuously. And this is your job, knowing the system, how to re-optimize consistently, continuously, do that job better. Cultural shift, it's on you guys. I don't know your organization. I don't know. I spoke with other organizations are actually open-minded. They think well ahead. And sometimes it's easier. And sometimes just talking, raise some awareness, talk about a specific issue, bring the data, guys. What you can see from this, it's completely data driven. At the end of this document, there are more than 90 research from validated entities, an organization, and a corporation. So what I'm trying to say is all these things are documented. Right now, with Solar, we have more than 20 years of data, historical data, patterns, problems. So it isn't like we're starting into hydrogen and we don't know what's going on or nuclear. Even in France, nuclear are quite solid on that. But what I'm trying to say is right now those issues are quite standardized, they're quite well known. So the point is skills. Do we want to invest technological? Tomorrow, I mean, I see a future where that technical expert can be the manager of tech identity and technical expert too. Because the site will not be able to perform if your team is not big enough or skilled enough or ready enough or enabled enough and the organization those structured or they're not in place. Maybe you say it's cultural shift. Why cultural shift? Because it's the whole approach of solving problems, maybe. The best problem solvers, they don't wait for the problem. best employees, they come to you with solution, not with problems. You don't want problems. You're the boss. You don't want problem. You have too many things. If you're the boss, if you're, we are not telling you, bring value every touch point. I think you get a promotion if you keep doing it. If you keep delivering, and this part of all this, I think it's being ready. Yeah, technology. We can talk about technology at this point. I mean, either if you want to invest in house, and I think you should do it. Honestly, I say it's better, always better, great to have a tech. And I've seen more individual right now with great technical expertise joining those solar companies, and I think it's great because meaning the industry is going toward the right direction. Um, People with the right skill set. Yeah, you want to use. I will skip that, but well, the whole point here is you want to pick the right tools. You want to be able to have the right enablement, and you want to be able to have the right skill set. I know you're technical engineers, and I had the same discussion with Matteo. He was a mechanical engineer working for years in a utility company. Right now, he's becoming almost a professor in AI machine learning. He knows the importance of predictive intelligence because he studied that, because he saw the impact. More than 100 million in savings, $100 million in savings with AI. Okay, it's no longer, I know right now there's a big hype, but why AI? Where should I go with AI? AI, AI, AI. Everyone is talking about AI. I think, and I think there is a hype side in terms of talking, but it's undervalued in the sense of impact to the system, which I'll say the advantage of solar, the IoT, which right now it can be enabled from the beginning with the new models, new system. Especially you are watching, are you from US, Dubai? Are you from an advanced and getting the best in terms of manufacturing, and you start new companies delivering the best hardware? You have way more intelligence than who was in maintenance 10 years ago. Who was in maintenance 10 years ago? Yeah, you have to do it like that. They have to rely on system, no alert, go on site, check that. You understand if you're watching the system, the history is changing. It's changing. It's no longer the same game. You need to be smart. You need to have smarter tools. You need to have a smarter personnel. You need to be enabled and trained in a different way, which sometimes they don't teach you that electrical schools and engineering school. I mean, right now they're starting, but for is getting to a job market right now, maybe we'll be ready. But for whoever is still in the job market with 20 years experience, it's on you to enable yourself. You realize that. You say, I never study AI. You don't need to study AI. Maybe you just need to start understanding the fundamentals in order to start understanding it, or be surrounded by people with a better understanding, or even just to choose who is the best, just to understand what you need. You talk with a vendor, they will say buy everything. Maybe you don't need to. Not everyone is completely ethically aligned, but it's fine. I mean, unfortunately, but what I'm trying to say is to have best decision come from the best concept context. To have context, you have the technical context. You need to have the technological context too. Right now, it's no longer just about panels. You know that. This is why you might watch this. It's about all the intelligence around it. And there is ton of it. Hundred of thousands data points. To not talk about millions. So here are some stats. Implementing forward assessment planning. We said that pilot implementation, 10% of your portfolio. Guys are small, good ROI, solid fundamentals. We have done. You do it right. We discussed that. Solar landscape. It's almost over. I would say 20, 30 minutes max. Is evolving. We know that. I was watching I think it was from Next Tracker. They are starting implementing robots, arms to start for construction. A lot of companies are doing it. IPP, a construction company. I mean, right now the big players, they have the money. They know they want to invest. And if you realize if you're in construction, you're relying on a team of manual workers. I understand you don't have maybe 1 million, 2 million, 100K to invest in a robot. It's not the point. What I'm trying to say is to raise awareness about where things are leading. Drones, robots, on-site, installation, analysis, data continuously is something will become more. Maybe you are below 1 megabits, you don't care. Maybe you are over 10, 100, 500. You know it's where the thing is, where the performance is. Now you need to be an engineer. You are an engineer, now you need to be a performance engineer. How you need to understand about tech. You need to understand about those tools because it's a new toolbox. You need to know how to use it. They're available. Big players are implementing it. They are using it. Autonomous system. Ideally, tomorrow you don't need a team. I mean, you have robots on site. You have drone that can autonomously be delivered during a box solution. So, what I'm saying, why putting those information here? You need to be aware about what's happening, what the leading players in the industry are doing. I'm not talking about something happening 10 years from now. I'm talking about something that's already happening right now. If you, out of this, you have zero implementation, nope. I understand it's a financial gain for your investors, so maybe they plan differently, they don't want to. But what I'm trying to say, there are players, big, with great P&L, great balance sheet, who are doing it. So you think, why I need to invest this amount? Because there is a financial return. Construction time, delivery, and employing people. I think a lot of what one point which is not mentioned enough, they will not be just in US. I think we are in a shortage of 50,000 workers the next years in the solar space with high electrical background engineering. So reality is people skilled enough will not be there, and you will have a lot to handle. How do you want to do it? Do you need a system? Do you need a smarter system to support you? Maybe. Maybe. Just saying. Performance digitization. So we can talk about AI agents. I will say, if you're interested about AI agents, you can do something. Get a demo. Go to our website. You don't need to watch it. We'll provide more information. You can even request this. I can get more into details. I think the AI agents will be the next step in the solar because once everything is planned and is done properly. We have seen a lot of problems come from the APC. And if you are in OM, they are on you, unfortunately. You couldn't fix them. So the reality is now, from now on, your scope starts. What do we do? In that sense, I will say, start thinking in the best way. For us, the future is smarter, IoT empowered sites with higher intelligence, more intelligence, autonomous decision making, direct root cause analysis from string, inverter, combiner level, where you can pinpoint and correlate problems. A human being who is not able to ingest this information. You know that. You have tried to do. I think you have tried to correlate that. Why is this problem? I see that even director doing it manually still. And they invest a lot in SCADA system. They have their system. I'm not saying they don't. They manage over 100, 200 megawatts sometimes. And they're still doing it manually, which is fine. But the point is, where do you want to spend your time? Validating information or trying to understand what is the problem and spending and talking with your team, which is nice, I think is. But at a certain point, you want to be effective. So yeah, we are leveraging a lot in the OM, yeah, agents. I think one of the most things is the performance agent for root cause analysis, because really based on all the data available, and we talk about this in this session, you really can get a lot of performance out of it. Thermal monitoring, we cannot push thermal inspection enough. It's something you need to realize from. So we always recommend start doing a POC, start doing a POC, start take 2-3 megawatts, run up, pick a pilot, write hardware expertise, go on site, see. I think there is nothing better at the end of the inspection. You see all the outputs and say, now I understand why it's not performing this. Now I see that problem. Guys, I repeat, if you don't see it, you don't believe it. And I agree. But do it. My recommendation, just do it once, you see. Just take a big sample, big enough sample to find the problem, because there are problems based on the aging of your sites, but most probably on the weather condition, you will find hotspots. And the next step will be, okay, why we have so many hotspots? What are the root cause of those hotspots? I mean, we even discussed some of them. Beyond detection, predictive workload distribution, we know that anomaly response, performance optimization, portfolio intelligence. Um, I will go. I think we can. I think we can close here. As in, I will say the immediate next step is what the rest will be available in this document. So whoever is interested about what we showed so far, um, please comment. Immediate next step: conduct a comprehensive assessment. If you're watching this, the first thing you could do tomorrow, ideally hope, do an assessment. We talk with people sometimes say, I have this problem. Did you perform an assessment in-house? No one performs assessment. They just have problems and they write down the problem, but make an assessment. Do it. 5 domains, quantifying both cost, performance gap. Calculate opportunity. Guys, normally I spend half of my time doing this. 20% on this, and the rest. You could do this alone, without a vendor, without anyone. Do an assessment. Do it right now. You finish this video, you start doing it. This Sunday will be posted on Monday. You watch this, some free time, book time on your calendar. Spend some time, go through what we said. Start making an assessment. Conduct it. You'll start seeing, evaluating. You'll start saying, okay, maybe I need that. Or maybe for this scale, maybe for the environment, maybe for those conditions, I need to start exploring this type of technology for this type of reason. And it's fine, but you see, this is the difference between people come to you and you say, I don't need that, and you go to them saying, I might need to explore that. And it's fine, but you see how much time saving and even how much awareness. You don't need to come on calls, since most problem, I talk with people that are not aware. I repeat, it's fine, but it's your responsibility to be prepared. Not for vendor discussion, but for what's going on, because this is your job. So, so yeah, prioritize initiatives. We said that ROI, 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 always. Engage shareholder, stakeholders, build the business case, secure executive support, necessary investment. Select partners, technology, service providers, pro and solar expertise. Launch pilots. Guys, launch pilots. Pilots, pilots, pilots. Pilots. You want to try, you want to see. And if you want to do it, you do it fast. Because if you want to fail, you want to make it fast. Ideally, you don't want to fail, so you want to be prepared to do it. So are you prepared with what we said technologically, financially, business-wise, internally? I think we went through the whole scope. Competitive landscape, guys, it is, it's thicker, the margin more than ever. I would say it's an interesting environment despite the geography, what's going on everywhere, from manufacturing, geopolitical situation. I don't know if you're in US, Europe. I mean, if you're in China, I think you're quite well equipped with a lot of panels. But otherwise, if you are in a growing economy still with EPC, OM, you know how much right now it's tough. It's tough. I know with people say it's tough. They love their job, but they're understaffed, so they want to have as much knowledge as possible. So I'll say I think we can stop here for today. So for whoever watched this hour of recording, I hope you learned something. I hope this data, which I repeat, everything was validated, more than 90 sources. So I will share this document for whoever requests that. What I want to say is, if you are exploring, it's great. If you're learning, It's great. The only thing is take your time, do it right. It's, it's not a sprint. It's not a sprint, it's a journey. This panel should last years. So take it slow, but take it right. Do it right. It's great. Honestly, if you're part of this industry, I think it's great it's a great industry to be in. And I think we'll time everyone, not just because we'll become the first renewable source of electricity, but we'll be aware of it. So thank you for watching. If you're an expert, I mean, I'm always open to connect and discuss and bring people with expertise on calls on an episode. Uh, for sure, either EPC, OM, or from IPP. Uh, we'd love to talk about performance, solar performance. We love about common issue practice. So please, connect with us from ClearSpot. You can raise a demo, request a demo, leave your name. We'll get back to you. And if you're interested in exploring any kind of integration opportunity, glad to connect as well. I hope you enjoyed this session. I hope it was useful, insightful, relevant, and hopefully you'll start implementing something. Just 5% of who's gonna watch will implement. I think I will consider myself satisfied. Otherwise, thank you for your time and see you the next episode.